Okay. So the worm starts at x equals 0 in this first situation. The worm starts at x equals 0 and moves to x equals 8 and then moves back to x equals 6. So let's draw this out. I'm going to put 0 down here. 0. All right. Way down here, I'm going to put 8. And then it's going to move to 6, so we'll put 6 over here, left of 8. Okay. So the worm starts off at 0, goes to position 8, and then comes back to position 6 right here. Okay, so this is where the worm ends here. All right. So the displacement, that term means the net distance traveled. Okay. So while the worm did go from down to 8 and then back to 6, the net distance traveled is from 0 to 6. That's the displacement. Okay, so that's 6 units. What about the total distance traveled? Well, the worm in total went further than just 6 units, right? So the worm went to 8 and then back to 6, which was 2, right? So the total distance this thing traveled was 8 plus 2. That was 10. Now, the final position, we can visualize this easily in this example because we've kept it very simple, right? The final position is easy to see. It is here at 6. But in general, the final position is equal to the initial position plus the displacement. Okay, in our example here, this is 6. All right, in this one, the worm starts off at x equals 1. It's going to move to negative 6, move to negative 1, and then end at 0. Okay, so let's just sketch this out here. I'm going to put negative 6. Let's go with green again. We'll put negative 6 down here to the left. We'll put x equals 1 down here to the right. That's as far to the right as the thing goes. All right, so it's going to start off at 1. It's going to move all the way down to negative 6. It's going to then move to negative 1. So let's put negative 1 on there, so like right here. Okay. So it comes back to negative 1. And ends at x equals 0. Okay, so here's 0. That should be more like halfway, but. All right, so it ends right here. And you can see it started at 1. So this is where it ends. This is where it started. All right, now let's look at the displacement. So just looking at this, you can see the displacement. It started at 1 and then ended at 0. So its displacement was negative 1. It went in this direction. Okay? So negative 1 is your displacement there. Thank you. The total distance traveled, well, let's take a look at that. So it went from 1 back to negative 6. How many is that? 7. Plus, then it came back from negative 6 and ended at 0. Right? So that's 6. You went to negative 1 and then to 0, but yeah. All right, so that's going to be a total distance traveled of 13. You see that the difference is really important here, right? Displacement is the net distance traveled. That could even be 0. But the total distance is always going to be positive, and it's going to total the entire path that the thing traveled. Its final position is going to be the initial position plus the displacement. So the final position should be 1. That was the initial position. Plus the displacement, which was -1, which should give us the final position of 0, and we saw that visually by when we were charting it out, right? All right, so here in this example, the worm starts off at 2, moves to 8, and then in 2 seconds, so now we have time, we're bringing time into this. It's like a second dimension, okay? So we have the worm still moving along the line, but now we're going to start a stopwatch for it moving, okay? So we have here, the worm starts at 2, moves to 8 in 2 seconds, stops for 2 seconds, and finally takes 4 seconds to move to 0, all right? So starts at 2, I'm going to put 2 right here. Then moves to 8, so we'll put 8 down here. So it goes like this from 2 to 8. Stops there and finally takes 4 seconds to move back to 0. So it stops at 8 for a minute, or not a minute, sorry. It stops for 4 seconds and comes back to 0. Put 0 back here. So it goes right there. Okay. All right, so take a second. Figure out displacement, total distance. So we should have had, go away. So we should have had displacement's -2, started off at 2, ended at 0.